Yeah, good evening, everyone. Just wait for 2-3 minutes. Hello, sir. Hello. हाँ सर, पेमेंट हो जाएगा इसका? ठीक, आज हो जाएगा ना? आप कर दीजिएगा, मेरा पहले आज कर दीजिए तो उसका करिए। ठीक, ठीक, ठीक। IIT Nanika. Okay, just wait. Everyone wait for just 2 minutes. I am having my lunch. Just let me finish it. Okay. Hmm, thank you. Hmm, hmm. Okay, let's continue now. We can start up. Am I audible to everyone? Saiti, everyone, am I audible?
Yes, sir.
Yes, sir.
Okay, let's continue. So, which topic we were doing? We had started with, I think, chemical effects of electric current, right? Had we started with chemical effects of electric current?
Yes, sir.
Yes, sir.
Okay, so let's do. So we had seen about the conductors that liquids are also conductors, right? Liquids can also be the conductors. Solids can also be the conductors. And among the liquids, we had studied yesterday about ions. So does anyone remember what are ions?
So they are stable atoms which have of any element, sir, which have full octet configuration.
Mm,
Sir,
yeah,
are you talking about ion?
yes,
Sir, ion, like if an atom has more electrons, it is it is a negative electron, negative ion. Sir. If it has less electrons, it is a positive ion. Sir. My dad explained it.
yes. So if we discuss about the ions, ions are atoms or groups of atoms which are charged. Okay, so atoms or groups of atoms which are charged. Just 1 minute, I'm sharing it. Okay. so- Okay, is there anyone whose exams have been over?
Sir, from tomorrow my exams start.
Okay, so from tomorrow your exams are starting.
And tomorrow is my first science exam.
Okay. So see, we had studied about all these substances, conduction tester, and everything we had studied. We had studied this tester also, which we call as the magnetic compass. A tester can be made using a magnetic compass also. All right. And electrical conductivity of solids. So we tested the electrical conductivity of solids by making a circuit and taking a bulb. Electrical conductivity of liquids is taken or understood with the help of two electrodes. Okay. So there are two electrodes which are dipped in the solution. They are separated apart. They are dipped in such a way that they do not come in contact with each other. Okay, like you can see here. So you can see here two circuits with two solutions and two electrodes dipped in between them. The liquid in the first one is a good conductor, whereas a liquid in the second one, which is which can be either a distilled water or sugar solution, kerosene, spirit. Now see, even sugar solution is okay. Sorry, I just faced a network disconnection. Am I audible?
Yes, sir. Yes, sir.
Okay. Okay, so this was the topic which we were discussing about the conductivity of the liquids. Okay. So we find here that those liquids which conduct electricity, they are either the solutions of acids or the solutions of bases or solution of salt. Whereas distilled water itself is a poor conductor, solution of sugar and all the oils, whether it be kerosene oil, whether it be cooking oil, whether it be petrol. Okay, so all the oils, they are poor conductors of electricity. Yeah. Now, the chemical which have been taken here or the liquid which has been taken. So the chemical which has been taken in this beaker, that chemical is called as an electrolyte. If it is a good conductor, we call it as an electrolyte. And the rods which have been taken, which have been dipped in the solution, these rods are called as electrodes. So here the two electrodes, they are similar. They are similar or they are identical. Now chemical effects of electric current. Starting from here, what are the chemical effects? When electric current passes through a conducting solution, it causes chemical reactions. This is called chemical effect of electric current. Like up to now, we had seen chemical reactions happening which produce heat and light. Okay. We had seen we had seen chemical effects like that, like formation of a chemical or two substances reacting. Okay, or there is a dissociation like reaction of carbon and oxygen. If we see the reaction of carbon and oxygen, so we observe formation of the gas which is carbon dioxide, right? So such a gas which is formed like carbon dioxide or any other chemical change which we observe. Okay. So there are different there are different chemical effects which can be seen. So for chemical effects, chemical effects means occurrence of some chemical reactions. So here in this chapter, we are looking at chemical effects of electric current. That can an electric current cause some chemical reactions? So is it possible for electric current to cause some chemical reactions? The answer is yes. It is possible for electric current to cause chemical reactions. For example, here we observe if we pass electric current through water, so we will see formation of bubbles. And the formation of bubbles indicates that there is some chemical change which is occurring. That means a gas has been formed. And a gas has been formed, that means obviously there has been some chemical reaction which is occurring in the solution. So this process is also called as electrolysis of water. A similar process which we call as electrolysis of water. Okay. So see how electrolysis of water happens. We take any solution. So here we take any solution. Suppose here in a beaker I take a solution. Here I take water. If I am taking here water, so distilled water is a poor conductor of electricity. I make this water a little bit acidic so that it becomes a good conductor of electricity. Okay. So when water becomes a good conductor of electricity so that it can conduct electricity, I dip two electrodes in it. So here I make two electrodes dipped in the solution. Now these electrodes when connected with battery, you have positive terminal, negative terminal. So when these electrodes are connected with the battery, so electric current starts flowing through. When electric current starts flowing through it, we observe formation of some bubbles at both the electrodes. At the positive electrode as well as at the negative electrode, we observe the formation of bubbles. So these bubbles indicate, now in this reaction what actually is happening, by passing electric current, we are breaking down water. So water is being broken down to hydrogen and oxygen. water breaks or it splits to give us hydrogen H2 and oxygen O2 by passing electric current. Okay. So if you are asked, is there any method by which we can separate hydrogen and oxygen from water? Yes, Nanika.
Yes, sir, there is. Where when we use when we put them through current with a little acid help, then we can separate H2 and O2.
Yes, from water we can separate hydrogen and oxygen by passing electric current. Okay. So this reaction is called as an electrolysis. Lysis means splitting up, breaking up. So electrolysis of water means breaking up of water by with the help of electricity. Yes, Pranav?
Sir, like how electric current will break down the hydrogen and oxygen.
How electricity is able to break down into hydrogen and oxygen. So this topic is actually you'll be getting in class 10, how it breaks up, but I just explained this to you in short. So in short, what happens? Your water molecule, when acid is added to it, it splits up to form ions. It split up to form hydrogen ions and oxygen ions. Okay. So in the solution, you have hydrogen ions as well as the oxide ions are present in the solution. So by passing electric currents, hydrogen ions, they are collected towards the negative terminal and oxygen ions, they are collected towards the positive terminal. Since oxide ions, they are negatively charged, so they will be collected towards the positive terminal and hydrogen ions are positively charged, they are collected towards the negative terminal. But hence, both of them, they are separated out, they form their corresponding gases and separate out from the solution at the corresponding electrodes. Got it, Pranav? Okay. Then what else can happen? This was one of the examples which we had seen as an example of chemical of effect of electric current. Okay. There are other examples too. For example, deposit of metal on electrodes. The electrodes which we dip in the solution, they make it deposited with some metals like okay, see, deposit of metal on the electrodes. So whatever electrodes are there, like here you have two electrodes and an anode and a cathode. So there might be deposition of particles of one electrode on the other. This method is generally used for uh, galvanization or also used to give a shiny look. Like suppose if you have some material made up of iron, you can give it a look of silver. You can also give it a look of gold by the method of electroplating. Okay. So electroplating is a method which utilizes electric current to transfer or just keep or deposit the metal ions on the other one. Yes, Lasya, yeah, it seems you have some doubt.
Yes, sir. So this cathode is like some copper.
Uh, we can choose on our basis. We can choose it. We can choose it to be made of copper. We can choose it to be made up of iron. This is our choice.
But it is not the cathode and the copper are not the same, sir.
The cathode and
Copper are not the same.
okay. See what we call as cathode and what we call as anode. That is beyond the scope of it. But currently, you can remember the one which is which is connected to the negative terminal is the cathode, and the one which is connected to the positive terminal is the anode. Okay. So the metal ions, they start moving from the positive terminal towards the negative terminal. Okay. So from the anode, there will be movement of particles from anode towards the cathode. Like if I make anode to be made up of silver, okay, so silver will get deposited on the cathode. Yes, Pranav?
So like the particles of the anode move towards the cathode to form a layer, no, sir?
Yeah, they move toward on the cathode to form a layer. Okay. So this method is called as electroplating. So can anyone tell why do we want electroplating?
Because to get a shiny look, sir.
Yeah, we want it's fashion. We want to get a shiny look. Okay. We want to have a look of gold. We want to have a look of silver.
For a
Okay. So
fast power supply,
which one?
for a better power supply.
Yeah, for better power supplies also. For better power supplies or easy, you can say cheap wires with the same capacities. Then
Okay.
next is change in color of the solution. So this is another change which can be expected out. If you are having any,
Sir,
yes,
sir, iron is a conductor, right?
iron.
Yes, sir.
Yes, iron is a conductor.
So when we electroplate it, so will it still be a conductor?
If you electroplate iron with a conductor, then it will be a conductor.
If
Okay.
you
If
electroplate with an insulator?
then it won't remain. Then see, then if you make a contact with iron, then only it will be conductor. It's just like if you have a wire made of iron and over that you wrap with plastic. So do you think that if you just make a contact with the plastic, so there will be conduction of electricity?
No, sir.
No. So that is the thing that happens. You got it? So got this?
I have a doubt. I have a doubt.
Yes. What's the doubt?
Like anode is the positive electrode and cathode is the negative electrode, no, sir.
Hmm?
Yes, sir. If anode particles are moving towards cathode, like in that from the cathode also it should move towards anode, no, sir.
From cathode to anode.
Yes, sir.
Which particles move from cathode to anode?
Negative particles.
Yeah, the negative particles they moved from cathode to anode, and the positive particles they moved from anode to cathode. Okay, but we see that the metal ions they are positive charges. Okay, so in the solution, the metal ions they move from positive anode to the negative cathode. Got it? Okay, so see, the first process shown here is the electrolysis of water. So as I told you, electrolysis of water, it is the process of splitting of water to form hydrogen and oxygen. You see, when an electric current is passed through water, it splits up into hydrogen and oxygen. This is called as electrolysis of water. So here, a 9-volt battery has been taken up, and when electric current is passed through water, gas bubbles are produced at the electrode connected to the positive terminal. See, we observed that I just told you that if you have water molecule breaks to give you
Yes, sir.
water molecules.
Hydrogen and
Yeah,
oxygen.
yeah. So H plus ions and oxide ions are formed. See, oxide ions are negatively charged, so they are produced at the negative plate. That is, at the cathode, you will have the production of oxygen. Sorry, at the positive plate. Oxide ions they are negative, so they will be moving towards the positive plate. That is anode. So here you will have the formation of bubbles which are oxygen. At the negative plate, you will have the formation of hydrogen gas at the negative plate, that is cathode. Got it? Just make a diagram. You can make a diagram for this where the oxygen is produced and where hydrogen. Yeah, any other doubt? Any doubt? So you can try this activity at home. If you have a 9-volt battery, you can take two carbon electrodes, dip them in water, and you will be able to observe the bubbles of oxygen and hydrogen. So you can really form hydrogen gas at your home. Okay, you can form oxygen gas. Now, a very important thing about hydrogen gas. See, hydrogen gas, it is combustible gas. It can burn. Oxygen is a supporter of combustion and oxygen gas burns. Okay. So if you burn oxygen gas, there is a specific characteristic by which we can identify that the gas that has been burned is hydrogen gas. Does anyone know how can we identify hydrogen gas? Yes. Does anyone know how to identify
Sir,
oxygen?
sir, can I tell sir?
Yes.
By bringing a burning match near it, we can see if it burns with a pop sound, and if it does, then it is considered as hydrogen, sir.
Yes. So it is the hydrogen gas which burns with the pop sound. So hydrogen gas burns with a popping sound. Okay. If you have no other gas burns with a pop sound, if you burn hydrogen gas, so it starts burning with a pop sound. That is an identification, yes, that the gas formed here is hydrogen. Got it? Now electroplating. So electroplating is also a method of bringing about a chemical change. Like here you can see an electroplating example has been done. Two examples have been shown to you. The in the first case, you have a copper strip and a metallic spoon dipped in a copper sulfate solution. In the second one, you have a silver plate and again a metallic spoon dipped in a solution. Yeah, Lasya, you have a doubt that uh, does friction can be increased by making the surface rough? The answer is yes. Friction can be increased by making the surface rough. Friction depends on two factors. It depends on the nature of surface and it depends on weight of the body. So these are the two factors on which the friction is dependent. So obviously, on a smoother surface, there will be less friction. On a rough surface, there will be greater friction.
Thank you, sir.
Okay, so got it now. See here what happens in the first case. You have a copper strip which is connected to the positive plate. Okay, so there is one doubt from Pranav, and I think this should be the doubt for everyone. Okay, just think of everywhere you have hydrogen. Around us, we have the hydrogen gas. So consider here, instead of having everywhere, let's consider here a chamber. And in this chamber, I have hydrogen gas. and here I put oxygen gas. So what do you think? Do you think that there will be any reaction between them?
Yes, sir. Like
Yes, sir.
water. What it will form water.
Okay, so according to you, they should react with each other to form water. Welcome back again. So your doubt was regarding the reaction of hydrogen and oxygen, right? So as some of you, as I observed that some of you guessed that hydrogen and oxygen should react with each other to form water. Okay. However, this is not the case. If you have hydrogen and oxygen both in the same chamber, they won't react to produce water. They are not going to react at all. There are some conditions which are to be met for the reaction between hydrogen and oxygen. And the condition is that either the temperature should be high, that means there should be fire so that the hydrogen can react with oxygen or it can start burning. Got it? So hydrogen, it will burn under two conditions. Either it reaches its ignition temperature, it is a fuel, or the second condition is that there should be the presence of an electric spark or electric arc. An electric arc, like there is a potential difference. So then hydrogen and oxygen can combine to form water. So this concept has been utilized in the concept of artificial rain. Everyone has heard about artificial rain. Okay. So hydrogen gas is sprayed over there above the in the atmosphere. That hydrogen gas is then over there electric arc is passed through. With the help of the electric arc, the hydrogen gas combines with the atmospheric oxygen to form water. The water that is formed over there, the water that is formed over there, it further forms clouds and helps in the occurrence of rain. Okay. So understood everyone that just the presence of hydrogen and oxygen, just if you have the presence of hydrogen and oxygen, it does not mean that they will react and form water. You can keep both hydrogen and oxygen in the same chamber. There will not be any reaction. Got it? Okay. So we'll see in the next class We'll see from this apparatus which I showed you, like the electroplating. So from the next class, we'll be starting or we'll start from here as electroplating. We'll try to understand electroplating, how it is done. Okay. If you want to make a metal electroplate with silver, so where should you put silver? Okay. If you want to electroplate a metal with gold, so what should be the gold and what solution should you be taking? That is also important. Okay. Okay, bye all of you. We'll see you again in next class. Today we had a lot of network disconnections.